Good afternoon, Tzohoraim Tovim, everyone. Welcome, B'nai Or, to our Tu B'Shvat program. Welcome to our guests. We know we have friends from Temple Sinai here. Ooh, I'm sorry. I have to troubleshoot this for a second. Sorry about that. That happens. Thank you. I am honored and excited to introduce to you this afternoon my sister, Tania Dadoun, who has been an English and Hebrew teacher for over 20 years. She lived in the East Coast for about 10 years and now lives in Tel Aviv with her husband and 3 children. She is an environmental activist devoted to saving as many mature trees in her city, as well as in her country and across the earth. She has been co-leading Critical Mass Tel Aviv Yafo, a monthly urban bicycle ride, for the past 3 years, and co-founded Truat Ofanim, an unofficial organization that acted out to promote bicycle lanes in Tel Aviv. She also volunteers for the school PTO, currently co-running a campaign to cease the use of plastic and disposable dishes in schools across the city. Tania started studying climate change when she joined Parents for Climate, a local Parents for Future group, and is currently taking more classes in Tania College Education. She is a UConn alumni and earned her master's degree in educational technologies with honors at the Open University in Israel. Tania, bevakasha. Tania, you're muted.
Okay. Sorry about that. What I was saying is that I have you guys on 2 screens over here. So I can see you guys here and I can present here. So let's start. So thank you very, very much, Cantor Galit, for this opportunity. And thank you guys all for coming. I'm very, very excited to be here. So it's Tu B'Shvat today, and it's a day to appreciate our trees. And so I'm thrilled to see that so many people are interested in hearing about trees and about the environment. And I must admit that I have spent sleepless nights preparing for this presentation. So please excuse me if I seem a bit hazy. So this is what we're going to do today. We'll start with some background and context, and then we'll look at some observations. We'll then have a think about responsibility. Who is already taking it? And of course, the highlight of this afternoon, the solutions to our problems. We will then see what each one of us can do to make a difference. We'll end on a personal note where each one can express their feelings and thoughts, or if you have any questions. And so before we begin,
is there any way, I'm so sorry to interrupt, can you move yourself slightly? You're almost like not in the camera at all, so we can't even,
right.
We can't even see you. So it'll be nice if you're more centered. Thank you so much.
Okay. I'm gonna, that's very, very important what you just said. But now I can't see people here. So I guess this is kind of useless for me, this screen here. Okay. I guess I can't see people. Okay.
That's me.
Yes, I don't. So before we begin, I want to give you guys a heads up. What I'm about to reveal before you today is going to be completely out of your comfort zone. So before we start, you have a choice to stay and hear a life-changing truth, or you can take the blue pill and we can leave as friends. So are you guys ready to take the red pill? I can't see you, so you guys need to respond with your voices.
Yay, we're ready.
Okay. Okay, so let's start with some background and some context. What is the context that has brought us here today? I'm just gonna use this for now. Get an echo of myself. Okay. So ever since the Industrial Revolution, over the last 150 to 200 years, we have seen some tremendous changes when we look at our society and our economic system. namely capitalism. But how do these changes encourage a destructive relationship with our environment? Let's have a think of what we had before that. So there was the feudal system. Feudalism means land ownership and an ordering of society. There were lords and peasants who didn't own their own land. Basically, they farmed for their overlords. For them, it was subsisting farming, just enough to survive, or often not enough to survive. It was stable, but it was very unfree, especially for those peasants who created most of the products. Industry started developing. And while the Industrial Revolution had already begun, or had already showed signs of beginning in the 1700s, the feudal system wasn't officially abolished until 1806 by Napoleon Bonaparte. So industries are developing in England, in France, and then they spread all across the world. But they're all based on capital. There's also a reordering of society. Capitalism is a system where people could climb the social ladder. And it was a huge trek from the country to the city where these industries were developing. So they had to move to the city. Urbanization plays a key role here. People leave their more recognizable environment, their friendly village where people knew each other, and the village rabbi or priest, their teacher, different figures in the community. And now these are replaced with city life, where thousands of people are entering cities of mass production to work in a factory. And so a new class is formed, the proletariat in Marxist terms. This new working class is all part of this new system of capitalism, which is based on mass production and exchange. The owner of the factory could make profits based on his ownership. This created a wealthy part of society, the ruling class, the capitalists. Capital accumulates and capital creates more capital. And these factory owners were the beneficiaries of this new system of mass production. So in capitalism, production is done in a collective form of labor, but the profits are reaped privately. The big contradiction. And so the main dynamic of the capitalist system is profit. Now, there's not just one capitalist, not just one factory owner. There are many of them, and they're all competing for customers to sell their products to because they all want to make a maximum profit. That means that this pressure of competition always forces the capitalists to press down on wages or to cut down costs, and therefore there's an intrinsic conflict between the capitalists and the workers within capitalism. Okay, so how does this affect our narrative? And does it affect what we're talking about? And how does it affect what we're talking about in terms of climate change and humanity's impact? So within capitalism and exchange on a marketplace that is competitive, the environment also becomes something that is to be traded, that is to be profited off. And that is because within capitalism, things or products are not valued based on their use value, but on their exchange value. So what that means is that products are not valued on what you can do with them or how they might help you as an individual or as a group or as a nation or as a collective, but rather products are valued based on what profit can be made off of them in a marketplace. An example of this is forest. In a very real way, a forest provides trees for humanity. There's an entire ecosystem within that forest, and it's very valuable in terms of providing the oxygen that we breathe and filtering CO2, carbon dioxide. And of course, it's home for hundreds and thousands of who actually keep that ecosystem balanced. But within capitalism, that particular property of a forest is not valued. The property that is valued within capitalism is what profit can be made off of the timber from the trees, because the timber from the trees is a natural resource which can then be processed enough in a factory or in a workshop and can then be made into furniture, which can then be sold on the marketplace. So what we see is that capitalism actually switches the value of the forest, and it becomes more profitable to cut down the forest than to actually maintain or sustain the forest. So capitalism prevents us with this big contradiction. We have a planet which is finite, from which the resources are being exploited in the name of profit, in the name of trade, in the name of economic growth. And this exploitation is still taking place, even though the science is telling us that we need to stop and that we need to find alternative ways of providing us with energy, to rethink about our lifestyles, and perhaps also to rethink about what we call progress. So let's have a look at where our progress has brought us to thus far. We're going to take a look at some observations here. Almost all of the information that I'm going to show you right now is taken from NASA's climate website, and it's based on state-of-the-art tools and instruments to get all of these measurements. So when we talk about increase in greenhouse gases, what are greenhouse gases, and what is it that we do every day that causes these gases to be emitted? So as we see here, CO2 or carbon dioxide, right over here, this big circle, is the #1 greenhouse gas. Other greenhouse gases include methane, nitrous oxide, ozone, and water vapor, which doesn't appear here, but water vapor is also one of the causes the greenhouse effect. This is a depiction of greenhouse gas emissions by sector in the United States only. And so we see the percentages. And here on the right, we see a similar distribution on a global scale, except for agriculture and transportation. Americans commute more than the average person in the world. So right now, when we talk about transportation, we talk about the burning of fossil fuels.
I'm sorry, is there a possibility to expand a little bit the slide? Just a little? ותאתי, את מדברת מה זה מהר, תאתי 1,000,000 קילומטר.
Okay.
Thank you.
I can't.
You can't, then fine. It's just very small. That's fine.
But you can enlarge it. You can slide your window to the side, and then that'll enlarge the slide for you. You see what I'm saying?
Yes, thank you.
Okay. So on the right, we see a similar distribution on a global scale. And when we talk about transportation, we talk about the burning of fossil fuels. Most of the world's transportation energy, 95%, comes from petroleum-based fuels, largely gasoline and diesel. What about electricity and heat production? That means the burning of coal, natural gas, and oil, the largest sources of global greenhouse gas emissions. So greenhouse gas emissions from industry primarily involve the burning of fossil fuels for energy at the facilities on site. For agriculture, it includes the cultivation of crops and livestock, as well as deforestation. And so everything that you see in front of you right now is actually an underestimation because it doesn't include the carbon that would have stayed underground, but we'll touch upon that later. All right, so we're emitting carbon dioxide. What's wrong with that? Let's take a look. This graph shows us the level of CO2, of carbon dioxide, in the past 800,000 years. As you can see, during the ice ages, carbon dioxide levels were around 200 parts per million. And during the warmer interglacial periods, they hovered around 280 parts per million. But what is exactly parts per million, you ask? Okay, this image shows 392 parts per million. This is not the current measure because this was made a few years ago. But the CO2 is represented by the blue and the red rings, as you can see in here, in this box here. And so seeing air like this makes the proportion of CO2 seem small, which it is. The point is, it doesn't take very much. Carbon dioxide is very, very potent. All you need is a tiny bit, more or less, to make all the difference in the world. Keep in mind that we do need CO2 to survive on this planet. Without the blue circled particles, without carbon dioxide, plants would die and the surface of the earth would be frozen. The red circled particles, representing man-made emitted CO2, are the ones that are changing the global climate. So I'm sure you've all heard of the greenhouse effect. It's actually something that we want, the greenhouse effect. It's something that we're dependent on to survive. And life on Earth depends on carbon dioxide. So if you take a look here on the left, what we see is the greenhouse effect, what it looked like up until a few hundred years ago. There were regular levels of carbon dioxide, methane, and nitrous oxide. They were created by normal life processes, trapping some of the sun's heat and preventing the planet from freezing. On the right, however, we see our current situation. The rampant emission of CO2 from burning fossil fuels has a detrimental effect. It traps excess heat and results in an increase in the average temperature of the planet. The sun's radiation can't escape the atmosphere when the level of greenhouse gases is so dense. So the heat gets trapped in that atmospheric layer, and this causes our Earth to warm. It's like adding layers and layers and layers of blankets. Back to our graph. In 2013, CO2 levels surpassed 400 parts per million for the first time in recorded history. Now, there's a clear and distinct relation between fossil fuel burning and this level of CO2. Today, we have reached a staggering 413 parts per million. If fossil fuel burning continues at a business as usual rate, then carbon dioxide will continue to rise. If this happens, the atmosphere would not return to pre-industrial levels, even tens of thousands of years into the future. What we have to urgently do, is to lower the amount of CO2 in the air. We have to lower our emissions to 350 parts per million by 2030 and cut down all emissions by 2050. Otherwise, humanity will not continue to survive as we know it today. To sum up, this graph not only conveys the scientific measurements, but it also underscores the fact that humans have a great capacity to change the climate and the planet, as our next slide shows. Now, what is a good way to reduce carbon dioxide? Trees. We've all heard of photosynthesis. Trees create glucose through photosynthesis. They take in carbon dioxide and release oxygen in the process. However, we're doing the opposite of that. Here's an example. In 2019, deforestation in Brazil's portion of the Amazon rainforest soared more than 88%. This is because President Bolsonaro had called for development of the region. So in less than 1 year, between 2018 to 2019, 1,762 square miles were deforested. That is an area larger than the state of Rhode Island. Over the past decade, previous governments had managed to reduce the clearances with concerted action by federal agencies and a system of fines. But this approach is being overturned by President Bolsonaro and his ministers. They actually criticized the penalties. So what we're seeing now is a dramatic fall in confiscations of timber and convictions for environmental crimes. In other words, the president of Brazil, his efforts to economically develop Brazil, at least in part, are coming at the cost of the country's irreplaceable rainforests, which are among the most biodiverse areas left on Earth. Today, 46% of forests across the globe are gone due to our so-called progress. This also has to do with precipitations. As forests grow and spread across a region, this affects rainfall. Forests create their own rain because leaves give off water vapor, and this later falls down as rain. Rainfall means fewer fires, leading to even more forests. Now, I hate to be the bearer of bad news, but researchers found that as deforestation gathers pace along with climate, more and more parts of the Amazon are expected to lose their natural resilience to a changing climate. They will become more likely to dry out and transition into a savanna-type ecosystem. But what does deforestation in Brazil have to do with us? Raising cattle. Cattle ranching has a massive impact on forests around the world, particularly tropical rainforests like the Amazon. Many farmers use deforested areas of land to raise cattle. However, it might surprise you to learn that corporations do this on a much larger scale. Fast food companies have been contributing to deforestation in places like the Amazon rainforest for quite some time, and only in relatively recent years have their actions been acknowledged by mainstream media. Companies responsible for deforesting the rainforest in order to raise cattle for their hamburgers include Walmart, McDonald's, Pizza Hut, and Burger King, just to name a few. Although some of these companies have made promises to be more environmentally conscious, some, such as Burger King and Pizza Hut, have made no plans to move away from this harmful and unnecessary form of animal agriculture. This is true to 2017. To summarize, deforestation is a significant part of the problem, but better management of the forests is an even bigger part of the solution. It's not just the carbon spewed into the air when a forest is converted into something else. It's that lost opportunity to keep that natural carbon capture and storage factory up and running. This process will come up again later in the presentation. Global temperature rise. So when we humans keep burning fossil fuels, and as we destroy the natural resources that balance them out, as we saw, we cause heat to stay trapped inside the earth. And that is what we mean when we talk about global warming. So global warming is the long-term heating of the Earth's climate system. These trends have been observed since the pre-industrial period between 1850 and 1900. And in these satellite images, we can see the effects of the heat-trapping greenhouse gases on the Earth's temperature. This graph illustrates the change in global surface temperature. Since the pre-period, human activities are estimated to have increased the Earth's global average temperature by about, it's 1 degree Celsius and it's 1.8 degrees Fahrenheit. It's a number that is currently increasing by I'll just say the Fahrenheit, 0.36 degrees Fahrenheit per decade. Currently, the warming trend is growing at an unprecedented rate that we haven't seen over decades to millennia. If the Earth becomes 1.5 Celsius or 2.7 Fahrenheit degrees warmer, that is a tipping point that some refer to as the sixth extinction or the end of the Holocene era. We're already experiencing a biodiversity crisis. Human activities threaten up to 1 million species of plants and animals. Today, extinctions are occurring hundreds of times faster than they would naturally. It's important to keep in mind that there is no single 1.5 or Celsius or 2.7 Fahrenheit degree warmer world. The impacts of climate change haven't been evenly spread out on our planet, and they won't be in the future either. Some regions are going to get wetter as the world warms. Other regions are already on the dry side and are only going to get drier. And this is already happening, people. Let's take a look at this screenshot I captured from an interactive map. Billion-dollar extreme weather events between 2000 to 2020. Here we can see specific extreme weather events depicted by the circles, their size reflecting their costs. We can also see the number of drought years over here, the coloring, where a range of 1 to 12 years is represented by the coloring, where darker red states are the areas with the most years of drought, and we'll take a deeper look into that in a moment. So first, let's check out a few examples on this map. The big blue circle on the bottom, as you've probably guessed, Hurricane Katrina, 2005. You probably know more than 1,800 people died, but did you know the price of repairing the damage that is costing you, the taxpayers, $170 billion? What about this wildfire in California in 2017? 54 people died, $18.9 billion in costs. And just one more example, we don't even know or hear about these events. Here it's called a severe weather event. It doesn't even need a name, with 12 deaths and $1.2 billion in costs. There's a link There's a link here for more devastating facts right over here, but we're not going to go into that right now. We will, however, have a closer look at drought here in the United States. Warmer temperatures enhance evaporation from soil. This means periods with low precipitation are drier than they would be in cooler conditions. So the drought we see here in Western North America that lasted from 2000 to 2018 is among the most severe to strike the region in the last 1,200 years. This drought, researchers say, was made 47% more severe by human-caused climate change. Similarly to drought, there's a new phenomenon entitled desertification, defined as land degradation in arid, semi-arid, and dry subhumid areas resulting from various factors, including climatic variations and human activities. When we talk about land degradation, we mean the temporary or permanent decline in quality of soil, vegetation, water, resources, or wildlife, for example. It also includes the deterioration of the economic productivity of the land, such as the ability to farm the land for commercial or subsistence purposes. The combined impact of climate change, land mismanagement, and unsustainable freshwater use has caused the world's water-scarce regions to become increasingly degraded. This leaves their soil less able to support crops, livestock, and wildlife. Rising temperatures means intensifying the Earth's water cycle and increasing evaporation. Increased evaporation will result in more frequent and intense storms. That means that rain, for example, won't be spread throughout time and space as much. Rather, it'll come down in a much shorter period of time and on less land. So while this contributes to droughts in some areas, other areas get flooded. We touched upon wildfires before. Climate change intensifies wildfires in the West. In this image, we see a firefighter trying to control a backburn as the fire spread throughout numerous cities near Redding, California in July 2018. Okay, all of this and more culminates with climate migrants. Here we can see displacement by country for the year 2018. In orange, people who fled because of conflict. In blue, people who were forced to leave because of climate change. The bigger the circles, the bigger the number of people. This is an interactive map to which there's a link here, but we'll just look at a few examples from the year 2018. So we can see that in Ethiopia, the numbers are extremely high for reasons of conflict. We could talk about imperialism, but not today. China, a staggering 3,762,000 people. What about here in the United States? 1,247,000 climate migrants. Mexico, 20,000. Guatemala, 27,000. El Salvador, 4,700. And the list goes on and on. We're talking about people who don't want to leave their land. They don't want to move to the city or to a different country. For example, this particular family had hope when they planted their last corn seeds in a rainy season after 5 years of hardly any rain. The corn sprouted into healthy green stalks until, without warning, the river flooded. Jorge sold his house to buy okra seeds. But after the flood, the rain stopped again and everything died. He realized he and his family had to leave Guatemala or they might die. There were 28 million new displacements associated with conflict and disasters across 148 countries and territories in 2018. 17.2 million people suffered to the point where they had to leave their homes due to disasters. That's 61% of all total displacements. Most people who are displaced cannot return to their home. Okay, I hope you guys are holding up because we've only discussed land up until now. Now we're going to talk about ocean warming. The ocean absorbs most of the excess heat from the greenhouse gas emissions, leading to rising ocean temperatures. Rising ocean temperatures also affect the benefits humans derive from the ocean, threatening food security and increasing the prevalence of diseases. Rising ocean temperatures also cause more extreme weather events and the loss of coastal protection. As we can see, there has been a 0.5 Celsius or 0.9 Fahrenheit degree rise in the ocean's temperature since 1950. Now, you don't need to be a genius to know that if you pour cold water over ice, that ice will last for quite a while. But if you pour hot water over ice, that ice will melt in no time. So this rising ocean temperature, as little as it may seem, has a big significance. Shrinking ice sheets, decreased snow cover, glacial retreat. Here, the North Pole. The more active region of the continent is, the South Pole, is West Antarctica, where many glaciers are accelerating. East Antarctica is larger, less explored, and more stable. And so what we see here is the movement of ice sheets represented by color. That's right, ice sheets flow like liquid water, just slower. The massive ice sheet moves ice from its interior to glaciers that feed the sea. Here we see a glacier in Alaska. Well, we don't actually see it anymore. From 1941 to 2004, the front of the glacier moved back about 7 miles, about 11.3 kilometers, while its thickness decreased by more than 2,625 feet, 800 meters. The Arctic sea ice reaches its minimum each September. September Arctic sea ice is now declining at a rate of 13.1% per decade relative to the 1981 to 2010 average. So we're seeing decreased snow cover of 3 million square kilometers, or 1,158,306 square miles. Here on the left, we see the amount of ice Antarctica gained or lost between 2003 and 2019. Dark reds and purples show large average rates of ice loss near the Antarctic coast, while blues show smaller rates of ice gain in the interior. The ice loss near the coast vastly outweighs the ice gained in the interior. So on the right, we see the Greenland ice sheet, as was seen here in October 2018. The Greenland ice sheet is melting at a rapidly accelerating rate because of Earth's warming climate. Greenland loses 283 gigatons of ice a year, while Antarctica loses 145 gigatons of ice every year. But what is a gigaton? How big is a gigaton? So here we not only see the numbers of what 1 gigaton is, because I don't know about you, these numbers are so abstract that they mean nothing to me. But we can actually see a visualization, and we can try to imagine what 1 gigaton is, just one. So if this is 1 gigaton, okay, this is in Washington, D.C., the capital, okay, and this is Central Park in New York City, okay? So that's just 1 gigaton. Can you imagine 428 of those? That's how much ice we're losing every year. And that is still such an incredible amount. It's really hard to imagine. But with a little help from NASA, we can actually see what this looks like. So between 1979 to 2020, we can see how much ice we have lost. If we look at the left and right images, the big ones. But why should we care about all of this? I mean, what difference does it make how much ice is lost in the North and South Pole? Well, as the ice melts into the ocean, it raises the sea level around the world. Not only does this cause flooding and other damage to coastal communities, more alarmingly, Losing ice from Antarctica's and Greenland's shrinking ice sheet means a sea level rise of about 20 centimeters. Most coastal regions in Europe have experienced an increase in sea level relative to land. Since 1993, global sea level has risen at an accelerating rate of around 3.5 millimeters or 0.14 inches a year. As the ocean warms, it expands, causing the level of the sea to rise. And since the temperatures are not getting any lower, we're expected to see the sea rise more and more in the future. But again, so what if the sea level rises? So we'll lose a little bit of land and a few million people will be displaced. Let's say we don't care about people we don't know, and we feel completely alienated from people on the other side of the globe. The problem is that glacier water and all that ice that's melting is actually sweet water. It has a very different chemical balance than the salty ocean water. So when tons of sweet water is poured into the ocean's salty water, that changes the pH balance of the ocean. And so fundamental chemical changes occur in the sweet water. Now, the ocean absorbs about 1/4 of the CO2 we release into the atmosphere every year. So atmospheric CO2 levels increase, and so do the ocean's CO2 levels. So initially, many scientists focus on the benefits of the ocean removing this greenhouse gas from the atmosphere. However, decades of ocean observation now show that there's also a downside. The CO2 absorbed by the ocean is changing the chemistry of the seawater. And as we can see in this process here, it's called acidification, ocean acidification. It's especially problematic for corals, oysters, and other creatures with delicate carbonate shells or skeletons, which are weakened by even very slight changes in the ocean's acidic balance. So we're going to watch a 1-minute video. I actually already have it ready over here.
את צריכה להתחיל לסיים, צריכה להשאיר זמן לשאלות.
אני עוד לא התחלתי בכלל.
את צריכה לסיים עוד 10 דקות את כל הסדנה. תשאירי זמן לשאלות. תחתכי מה שצריך. We're not seeing the video. It's supposed to be on?
Oh, yes. Yes, you are.
I'm not.
You're not, you can't see the video?
Can other people comment? I can't see the video.
Cannot see the video.
Cannot?
Cannot.
Can you
Cannot.
hear the video? Can you hear
No,
the
black
video?
screen. Black screen. There's nothing on.
Okay. 1 second. I'm just going to try something else here.
Yeah, maybe you didn't share sound or something.
I think I did, but okay.
Do it again.
Let's try that again. Hold on. Where did we say we start from 50? Hold on. Can you guys see my screen or no?
Now we can. Now press play so we can see if we can hear it or not.
Yeah.
Lowering of the pH.
Yeah.
Okay.
Now it's good.
Corals. Coral is an animal made out of calcium carbonate. It looks like a tree or a rock. If you just drop a little drop of acid on any of those, you'll watch them bubble away and dissolve. It's not that dramatic in the ocean, but it's just slowly becoming more difficult for these organisms to successfully shock. Another problem that coral reefs are experiencing is something called coral bleaching. Small algae live right in their tissues. Corals get energy from the sun that way. If the coral gets stressed, it kicks those algae out. Warming in the oceans is causing these corals to become more and more stressed, weaker, or dying. It turns from a beautiful color to white because the algae give the coral its color, and you can see the skeleton underneath.
Okay. Actually, there's I have so much more for you here, and Galit just told me that we only have about 10 minutes left. I thought we had an hour and a half today. Didn't we have an hour and a half?
Nope. We have an hour and 15 minutes for questions at the end. So we're there.
Okay, so let's have a think of what we should do because I need to think of what we can skip. I'm just gonna run this by you and without too many explanations, and maybe we can session and elaborate on it some other time. So we do your questions. So we talked about sea level rise. We talked about ocean acidification. The last thing I'm going to tell you about disasters is permafrost thawing, and I will not go into too much detail. The only thing I will tell you, I won't explain this whole thing. I will tell you that the dangers of permafrost thawing is not only microbes and viruses and bacteria that come out into the environment, into the surface of the environment. That's one of the biggest problems, and we all know what it's like when new viruses appear on Earth. What that leads to, but the more dangerous part is it's just a 30-second video that you have to see what happens when permafrost thaws and methane is released. And I already have this. It's just 30 seconds.
Methane is a very potent greenhouse gas. A molecule of methane is 25 times stronger than carbon dioxide. Methane is formed in millions of lakes around the Arctic where permafrost is thawing. And each year, these lakes are emitting already tremendous amounts of methane. But when we look at how much carbon is in permafrost still frozen, and the potential for that permafrost to thaw in the future, we estimate that more than 10 times the amount of methane that's right now in the atmosphere will come out of these lakes.
Okay, so okay. Oh, is that coming from me? Oh, sorry about that. Okay. What am I doing? This.
Maybe in the last 5 minutes of the program, you could just talk about how we can be active, what we can do, and then
yes, I can. Yes, I can. Yes, I can. I just want to see what's really crucial here. Okay.
טניה, תתקדמי, זה חייב להיגמר עוד 5 דקות, תתקדמי.
Okay. We talked about
Yes, we can. That's Obama.
Okay. Let's not talk about responsibility. Let's not talk about when we found out about this. Let's not talk about any of this stuff. Do you guys know Greta? Do you know who this little girl is?
Yes, we know Greta.
Okay. I have to show you. I just have to show you that, all these terrible things that I didn't even finish explaining about. People, there's a lot more awareness today. And this is what we need. We need to raise awareness and we need to act. I have to show you this. I'm sorry. This is the highlight of the presentation. This is a story I recently heard about, and I have to share this with you because I'm devastated and appalled at what happened. And this is happening here in your country, in the United States of America. And I don't know if you guys have heard of this man, but everybody needs to know about this.
30 Nobel laureates have joined global human rights and environmental NGOs calling for an end to the home detention of human rights lawyer Stephen Donziger. Donziger played a key role in winning the landmark $9.5 billion judgment in Ecuador against Chevron for its deliberate pollution of the Amazon rainforest while operating as Texaco from 1964 to 1992. He has become Chevron's target in the company's stated campaign to, quote, demonize Donziger, unquote. In 2011, Chevron was found liable and ordered to pay $9.5 billion for deliberately polluting the Amazon by dumping 16 billion gallons of toxic waste into the rainforest, causing a massive health crisis. Instead of paying the judgment, Chevron withdrew its assets and fled the country. 916 toxic waste pits remain, poisoning the local drinking water to this day.
Okay, I'm going to stop here.
Chevron.
I'm going to stop here. You get the point. I heard about this story recently, and I am really, I am devastated that this man, who is a civil rights lawyer, is still, till this day, in house arrest. And instead of getting Chevron to be accountable for the horrific things they have done, Chevron continues with business as usual, while this man who tries to protect innocent people and our environment is under house arrest. This is still going on today, people. So much for home of the brave, more like home for the brave. There are solutions. The solutions is that we have to stop fossil fuel burning, coal burning, and natural gas burning, and we have to stop deforestation. We have to move to renewable energies. This is the big thing. Renewable energies. I would have liked you guys to see this video and examples of renewable energies. I will leave you with this great note, with this great news. Remember we talked about desertification. This is actually in China. This is people replanted this place. It's possible. We can change. We can make a difference. This is another perspective of the same place. This is also a rainforest. This is in Brazil. Rainforests were replanted and rewilded. It is possible to make a difference. The coral reefs. I would have liked you guys to see the end of the video and see that humans can replant coral reefs. They can grow them in nurseries and then plant them in the oceans. And that's also another solution. Now, people working individually, that's not going to work because we need our governments to make a change. Because as we saw, there are tipping points and everything is connected to everything. And we need governments to work together and make a change. We saw that with coronavirus, emissions were lowered drastically. And we're on the right track, okay? President Biden has already said he's going to rejoin the Paris Accord, which we didn't talk about. And this is the main thing, people. This is what I really want you to be aware of, is that there's already a plan. There's already a plan for the 139 countries in the world to make the transition to 100% clean energies. The plan is already out there, okay? And I would have liked to tell you a few more things about it. The only thing I will leave you with is that this plan that I just told you about, the 100 renewable energies for 139 countries, that'll cost the world about $2.9 trillion a year. Now that sounds like a lot, right? But the thing is that the fossil fuel industry right now, every year gets more and more monies in subsidies from the world, okay? And in 2017, countries around the world paid the fossil fuel companies $5.2 trillion to fossil fuel companies. Now, again, I'm not a math genius, okay? But I think 5.2 trillion is a little bit bigger than 2.9 trillion a year. And so what is it that we can all do to make a difference? Of course, we have to act now. We have to reduce, reuse, recycle, refuse. I was going to go over these examples, but we're running out of time. Divert your money. Very important issue because governments also can't do it on their own. Every single change has to come from the bottom and from the top at the same time. Because if governments will just make a change, that's not going to help if people are not going to take responsibility. And if people take responsibility without the government support, making it something global, that's also not going that's also not going to work. So we need to also take responsibility. When we divert our money, we invest in fossil-free companies, in green companies, in companies that do not invest in fossil fuel burning. You can support green initiatives. This is an amazing initiative, by the way. It was established. It was founded, by 2 Israeli guys. It's called Time. This is My Earth. And what you can do is you can purchase collectively, communally, land on different places in the earth that they rewild and forest and that they maintain. And so it's like your little share, your little part of the world that you contribute to our environment. Get educated, learn, find out, go into different websites to see what's going on. I mean, for me, preparing this presentation, I mean, I'm always, learning about this and learning more and more, but making this presentation, I realized there is so much information out there. Make sure you get reliable information. Go to NASA's website, go to the IPCC, which we didn't talk about. And of course, you're not alone. Join the green movement. There's Extinction Rebellion XR in the United States. I looked into parents. I'm in Parents for Future, but I looked into Parents for Future in the United States, and it seems to me like they're not as together yet. So maybe you guys are going to do that. Maybe somebody in the audience today is going to start a Parents for Future group, or maybe you guys can join XR. XR has 3 demands. They want governments to tell the truth. They want governments to act now, and they want governments to go beyond politics and have social assemblies of people that are involved in decision making, and not just not everything being centralized and coming from above. Last thing that I really urge you to sign the petition to free Steven Donziger, to spread the word. I mean, spread the word about this man that is sacrificing his life for us. I mean, it's really the least we can do. And of course, talk about climate change and all of this to people, because when we talk about it, it's really, really helpful. And we raise awareness and when we do things, it's easier for us to deal with this very, very, I'm sure that that this may have been traumatic for some of you guys. And so I would really like to, at this point, really hear your thoughts and questions. I know it's not easy, and you guys didn't even hear the half of it. So I feel like I've kind of left you, with many questions unanswered. So
I'm going to thank you very much for all your work. And this has been a lot. And I'm going to invite everybody to stay on for a few minutes if they can. This is kind of the ending of our lunch period, so I want to respect people's time who have to leave. And I'm going to stop the recording at this time. And everybody who wants to stay on and ask questions. And I had a request here by Nancy. Thank you. If you could share if you could share your presentation, we would love to maybe post it and people could keep on looking at the information on their own. So I'm happy to do that also on the YouTube and post a link on